Assalamualaikum everyone. Welcome to the Eduverse, a universe of learning. I hope you all are doing so well with your families in a very good health. So the today topic we are discussing about is the branches of physics. As I have mentioned in my previous lecture that next we will study about the branches of physics. Uh, Before getting toward the branches of physics, here the question arises that why we divide it into branches. Here, why we divide it into branches? As we know, physics is very vast. Everywhere you see, everywhere you look, even inside the earth, outside the earth, in the earth, universe, space, all that, everywhere is physics. So it became very much difficult for the scientists to study about everything simultaneously. So they organized it into branches. It divided the physics into branches according to their properties, according to their laws, according to their formulas, according to their conditions, according to their areas, according to their uh, I hope you are getting what I really want to tell you. According to these properties, they have divided it into many branches. So, what was the reason and what were the essential for that? It becomes so much easier for us to study the specific phenomena as divided into different by different according to different properties, because then it will easier for us to like what formula is to be applicable for this for this type of properties. So it become very much easier for us to understand the specific phenomena and the specific branches. Let's dive about the branches, and the first one is the classical physics. Classical physics is, if you look about its name, classical is referring toward the historical, meaning the early approaches of the physics, like how scientists studying about the objects. And classical, the main thing about the classical physics, it's as a it actually about the objects we can see with our naked eyes, about their motions, about their forces, about their energies, and all that. So it's actually about the motion of the planets, motion of the car, motion of the objects, any type of object, and about their energies, about their forces, in which direction. All that is the work of the classical physics. As we have the definition, classical physics deal with the laws of motion and forces that govern the physical world we experience daily. Yes, I have mentioned that we can see with the naked eyes. We can see the cars moving, the cycle moving, the earth moving, and all that. It covers the phenomena that are observable and predictable. It, as again, it's a thing I have told you that it actually working about the phenomena that we can see. Car we can observe, we can predict about, like if it has the motion over here and that much speed, it will have at this time it will have that much speed. So we can predict about the future condition of that object as well, without needing advanced mathematical or the quantum theories. Means without diving about the very difficult mathematics, very complex mathematics, we can easily we can use the easy laws for the finding about the speed, for the finding about, or even only study about the objects. The key areas: mechanics, motion, forces, energy, all that I have mentioned, that the all these is the key areas of the motion of the classical physics. The another one is thermodynamics, heat and temperature. That's also the working of the classical physics. Optics, light behavior and properties, and acoustics and sound waves and vibrations. So all this about the classical physics. The next one we have the modern physics. As I told you that classical physics is actually about the massive objects, the objects we can see with our naked eyes, but there is a world inside the atom that we cannot see with our eyes. Right? We cannot see even an atom with our naked eyes. So the physics is day by day advancing about everything and enhancing. So they are also probe about the atom. So for studying them, classical mechanics cannot explain that phenomena. Classical mechanics, in the study of the all that is beyond the limits of the classical physics. So we need about the different new physics, like the modern physics, the modern laws, modern formulas, modern approaches, modern studies. So that's why we move toward the modern physics. This branch focuses on the phenomena that the classical physics can't explain. It includes the study of the atomic and subatomic world and the nature of the space and time. All that I have told you. Key areas: relativity, space, time, gravity, all that is the working of the modern physics. Quantum mechanics, the very huge approach, and all that behavior of the particle at atomic levels, and even it working for the atomic levels, energy levels, the energy level in which the electron are moving. Particle physics by fundamental particles and forces, the structure of the particle and structure of the atom inside the material. All the studies by the particle physics. So all these are the key areas of the modern physics. The third one is nuclear physics. If you look about its name, nuclear means nucleus. Nuclear physics is actually about the study of the nucleus at the center of the atom. It investigates nuclear reaction, radioactive decays, and how energy is released from the atomic nuclei. Uh, as we know that the electron is the fundamental and outside the nucleus, but inside the atom nucleus there is a nucleon. Nucleon means proton, neutron, and all that. The neutron also is a consist of the quarks. We can call it quarks, and the quarks are actually connected by the gluons. So it's the study about them is actually by the nuclear physics, and the key topic of the nuclear physics is, sorry, the nuclear atomic nuclei structure, the nuclear structure, studying about that nuclear fission and fusion. Here is the word energy, like there is a nucleon inside. If we are moving away them, the energy will be coming out. If we are want to move them close to one another, we will give energy to it, and all that the energy giving and emitting is the study of the nuclear physics. Nuclear energy application, like where the nuclear energy can be applicable for our daily uses, for our essential works, all that the study of the nuclear physics. The another one is atomic physics. If we look about its name, atomic, atom, the properties of atom and the structure of the atom. Atomic physics focuses on the structure and behavior of the atom, especially the arrangement and movements of the electron around the nucleus. It helps explain many natural phenomena and form the foundation of the laser technology and spectroscopy. Atomic physics. Atomic physics is actually about the atom, how the electron is arranged inside the atom, in the energy levels, in energy shells, all that, and how they are behaving with another atom, like the atom is behaving with another atom by interacting with another atom by their valence electrons. So the study, like how they are interacting with one another, is the key aspect of atomic physics. Key topics: electron configuration. Electron configuration means that the atom consists of the, different shells, orbits, and electrons are separately distributed among them. So that electronic configuration managed all that distribution. Like in first one, how much will be in the first one, how much will be in the second one, how much will be in the third one, how much will be in the suborbital orbitals, the according to their spins. Ionization and energy level mean that when we give the energy to the atom, the electron will move up, how much it will move up, and on how much energy. All that is the study of the atomic physics. Atomic spectra: when we give energy, the electron moves to the upward and to the upward orbital, and it emits some energy, and that energy has some spectrum pattern. Studying about that, and that pattern is actually different for different atoms, and studying about that spectra is the work of the atomic physics. Electromagnetism. If we look again about its name, electromagnetism. Electro mean charges at rest, having the electric field, all that. Magnetism is the two type. Magnetism is one from the magnetism generated from the moving electron inside the wire or anything anywhere, it produces magnetic field around it. And the another one is the naturally occurring material, atomic materials, like they have the atomic magnetic field. All that is the study of the electromagnetism. This branch studies electric and magnetic fields and how they are interacting with each other and matters. It essential in understanding electricity, current, magnetic material, and electromagnetic waves. When the electric charge is at rest, it has electric field only, but when it moves, it has both electric field and magnetic field. Both it has. But when study about the study is actually working for the how the electric magnetic field attract with one another. All that is the working of the electromagnetism. Key topics: electric field and currents. Electric field and currents, like the electric field of the static charge, and current when it's moving in an area. So it's about the electric field and currents. Magnetic field, when we are moving, or either of the static, naturally occurring magnets, about their field. All that is the study of the electromagnetism. Electromagnetic waves. Electromagnetic waves mean radio waves, light waves, the X-rays, etc. All that is the study of the electromagnetic, can be studied by the electromagnetism. So its branch is actually working and actually plays a vital role in our daily society, like the electricity, circuits, electromagnetic materials, electromagnetic waves. All that is very vital in our society. So next about thermodynamics. Thermodynamics, again, look about its name. Thermo mean thermal energy, heat, all that refers to that. Dynamics, moving of the heat energy, thermal energy, how it is created and how they are moving. Thermodynamics deal with the heat, work, energy, and how they are interacted. It explains how energy moves through the system and governs everything from the engines to the ecosystem. Heat. Heat is the energy. It's the amount of the kinetic energy inside the material. It's the energy, and that energy do some work. All that studies and their relations, how they are working, how they are generated, how what are the impacts of that. All things is the study of the is actually the key area of the thermodynamics. Key laws, there are some famous laws inside thermodynamics, like the zero law, so the third law, zeroth law, first law, second law, and third law of thermodynamics. The very vital inside of the thermodynamics. Heat engines and efficiency, like the heat engine we are using in the our historic era, that the first the production of the heat engine produced, and their efficiency, how much they are efficient, and how to uh, make them more efficient, is the study of the thermodynamics. Entropy and the thermal equilibrium. Entropy, we have the disorder of the heat system, like the heat that is emitted or the goes out from the any object, that the heat that we cannot use again, that is actually called as entropy. And the thermal equilibrium, when the two bodies are come into the thermal equilibrium, and even a single body with thermal equilibrium with the environment. All that studies is the actually the key area, key laws, and key all that for the key concepts of the thermodynamics. Here we have some little bit using the virtual phenomena, all that. So the next one is optics. Optics explores how light behave and interact with the material. It includes both the reflection and refraction, as well as more advanced ideas like the diffraction and polarization. Optics is actually about the light, how light is behave on the or by falling on the a specific object. When we fall on the prism, it will move in seven different colors, like it's the behavior. So studying this behavior is actually the work of the optics. Okay. Key types: geometrical optics, mirror or lenses. Yes, there is a phenomenon: reflection and refraction. Reflection means when the light fall on the object and reflect back totally, or even a little bit, that's the reflection. When it's passed to the that object is a reflection in all that things. Here mirror and lenses. Mirror, that can be reflected only, and lenses, that's another thing that we can pass the light on it. Physical optics, interference and diffraction, all that. Fiber optics and lasers. Fiber optics, wires we have nowadays in our life, and lasers, the beam of strong wave light wave. All that is the study of the optics. Astrophysics and cosmology. These field astrophysics. Astro means astronomy, all that, studying about the universe, about the earth, about the universe outside the earth. This field explores the universe beyond our planet. Astrophysics applies the physical laws of the stars, planets, and galaxies, while the cosmology looks at the universe as a whole. Means that astrophysics applies physical laws on the stars, movement of planets, movement of stars, and destruction inside the planets, destruction stars moving, and all that movements inside the galaxy, while the cosmology just look for the at the universe as a whole, its origin, like how it is created, how it's evolved with the time, and how will be its future. All that is the working of the cosmology. And that's about this branch. We have the last but not the least, I think this one is the geophysics and biophysics. Geophysics is a geology, means the world, uh, upside the world, like the earth we are seeing. Geophysics studies the physical processes of earth, like the earthquakes, magnetism, gravity, and all that. Like the earthquakes happening or disaster inside the earth, that's the working of the geophysics. And the biophysics applies the physical principles to the biological systems, helping to understand life at molecular level. Biophysics is actually applying the physical laws of the biological systems, helping for the understanding the material, about their half-life, all that something. Earth magnetism example, and the gravitational field. Geophysics, molecular biology, DNA mechanics is the key areas and example of the biophysics. All that about the branches. The many faces of physics. Physics is not just a one subject, like just not just one concept. It's a huge, it's a very diverse and vast universe with having a lot of different concepts, different areas. All that is the uh, faces of the uh, physics. So the physics is explaining how the universe works. The universe word mean all that happening, what happening in this universe is actually can be explained by physics. So physics is everywhere. All that about the today's topic. Thank you for watching. If you get it helpful, then please like, subscribe, and share with your friends, with your colleagues, all that. The Eduverse will always become for you, and other coming values will become soon, inshallah. And one request I can tell you, I can be placed for you, that if there is anything I have to improve in my lecture, so you can comment it. You are free, you can say anything, what type of confusion you have, what type of suggestion you have, you can feel free to tell me that. And yes, you can do it in the comment box, or even you can send me on an email. All that is free for you. You can contact me anytime. I will send you back the email, inshallah. And one another thing, if somebody needs notes, I have different type of different notes in a very organized way. So if anybody wants notes, I will provide them on a very cheap values. And cheap value, I mean that little bit cost I will cut on that. So that's all about for today, and thank you so much for your time. And thank you. Allah Hafiz. Well, meet in the next lecture. Thank you so much.